All right, today we're going to start in on my notes, my steps for database design. This is, if you will, my methodology. Maybe it's closer to my technique, using some of that systems terminology that you're learning. It may be a technique, maybe I'm following kind of the same steps Hernandez is, but this is my way of developing a new database. Now, I think one of your questions that I remember is, what if there's an existing database? You just use it? Well, no, not really. What we're doing in systems right now, in the systems implementation class, fourth semester class, is redeveloping a desktop application to be used on the web. Right, and that application already has a database. Close that, please. Already has a database. But what I have done is basically pull the fields out to start with step number one here, fact finding. I've pulled the fields out of the database. I did it. And then gave it to my students and say, here, if you had this field list, what would the database look like? And I'm hoping to improve the layout of that database now in the second iteration of that program. So if a database already exists, even if it's in third normal form, it should be analyzed. And the best way I think to analyze it is to almost build it from the ground up, unless you're in a real time crunch. And then maybe that's not such a great idea. Or unless you've built it when you were very skilled. And one of the things I mentioned in my notes, or at least in my recordings, is until you've designed about 25 databases, this is hard. And you probably, if you look at it again later, would say, I'll do this over, I'd do that a little differently. So it takes 25 database designs. Right now I'm on number 17, me personally. So I'm not all that perfect at it yet. I look back at other databases that I've built, so this is pretty good, but I would maybe do this a little differently, do that a little differently. And what my systems implementation class, what I'm seeing there is there's 10 of them in there, and I've asked them to design this database individually, and they're coming up with 10 different answers. And they could all be right. They're definitely all third normal. So this is kind of like writing programs. Every one of them could be a little bit different, but every one of them could be right and solve the problem. And so there's no straight answer, but if there isn't a database, these are the steps that I go through. Right. First and foremost, fact finding. What do you want in this database? Tying this into your systems analysis class now, this is the analysis phase. What are the requirements? What data do you need to store? And where you gather that comes from all kinds of places. It can come from an existing database, like I said, if you have one. What I tried to do when I made that field list for my existing database was not designate the table names, but just here's the fields that I have to store. But sometimes they just fall together, because I would list the customer first name, last name, address, city, state, zip code. That's probably one table. And I could split all those up to make it complicated, but they just fit so nicely together that I just keep them together. And so sometimes that field list is already partially sorted, organized into a list of tables. We can also get this from looking at reports. What information are you trying to get out of this database? I remember from the systems class the difference between data and information. We're finding a way to store the data. One way to figure out what data you need to store is to take a look at the information that's coming out the other end. How do I generate this information? And then build your field list from there. In the systems class, we talked about interviews and how much fun those are, how time consuming they can be. There might be existing forms that people fill out on a piece of paper. For Lions Camp, it's a 6-page form that people fill out just to come to camp. And then there's another whole form for medications. And we can take that form and say they want people to give them this data, because that's really what that form's all about, is collecting data. They give us that data to do the job. So this is where a lot of this stuff can come, and those aren't the only sources. You can do interviews, you can do observation, you can have meetings and say, what do you want? Similar to interviews. Forms, reports, existing data. Use all that as your starting point. Now, what I want to cover today very quickly is these 10 steps that I have you go through, and it's not even 10 really, it's only about 9, but I call them my 10 steps just because it's a nice round number and 9 is not. Okay. So we're going to go over those relatively quickly, and then we're going to go back and start the process and actually design a database. Lyle, you had a question about the GUI. You got it in front of you there?
Yeah.
Go ahead.
Well, I just said once the GUI is connected to the database, can the queries be ran with that, or does it have to run programs to be linked in order to run the process?
Okay. So his question, just so he hits the recording here, is once I've got a GUI connected to the database, can I still run any query that I want to? The answer is generally no. The GUI is set up to run fixed queries. Those reports that I just mentioned, when do you run those? Once a year, once a week, once a month, but I know I'm going to run those reports. I can write the queries for those reports. But ad hoc queries are very difficult. And that's kind of where you as a database administrator or a database programmer come in and somebody says, I need this information out of the database. It's not on any application that we've got anywhere. Can you get that for me? And as long as the data is there, the answer is yes. But putting it into a GUI complicates that issue. How do I get it back out again? But we're going to ignore the GUI. There are no GUIs here. We're doing database design. That's complicated enough. Then we're also going to learn, you're going to learn how to become that database. Some people call them database programmers, database analysts. Not a database administrator, unless it's a very small type database, but an analyst, somebody who could get data out of the database that nobody anticipated they wanted. That's the purpose of this course. Programming logic, intermediate, there we're going to be building the GUIs tied to the databases. So this class, that class doesn't talk anything about the database design. Though it's hard not to now that you guys are in this class. All right, tends to flow into that class. One of the things I was talking to Catherine yesterday for a little while, and one of the things I like about this RDD class being here in this semester is it correlates so well with systems analysis, correlates with programming logic intermediate, and for those of you who are at all three with me, I'm sorry, but notice there's a lot of discussion back and forth and in and around in the other classes. It's like almost like it's one big class because they're very closely tied together. They are. But there's these little distinctions. You know, we got to have this database, though I'm hearing that the Agile methodology, you don't need a database. We'll build a database as we do the Agile stuff, and we'll just keep adding more and more and more to the database. Okay. Val, was it your question about flexibility, or maybe somebody else's? I had a question about, Bill, how do you know that the database is flexible? Jess?
It means that data can be retrieved in a limited number of ways, so how can we know this or test for it?
How can we test for it? Okay, wait, actually we don't. We design for it. Okay, so how do we test it? Up at the top of my 10 steps, what I'm looking for here is a database. Sorry, I guess I could make that a little bigger, not that big. What I'm looking for is a database that is adaptable. I can add fields to a table without having to redesign the whole blooming thing. I can add tables without starting over. Then comes the flexibility. If we follow these 10 steps, what you get is a third normal form database. If it's a third normal form database, you shouldn't have any trouble being flexible and extracting any data that you can imagine that's in there somehow. Okay, so the flexibility is part of the end result of this design process. Does that answer it? Not really, right? How do I test this? Well, it's like saying I have a bucket of Legos. I can put them together in any way I want to. How do I test that? It's the design of the Legos that I can put them together in a lot of different ways. And so this is kind of the same thing here. If I build my database properly, and that's what these 10 steps are for, I should be able to get any data out of it regardless of where it's stored, as long as it's in there. If I don't store anything about hobbies in the Wisconsin Lions Camp database, I can't get all the people who are coin collectors coming to camp because I don't have that information. I don't have that data. Excuse me. I don't have that data, so I can't generate that information. But if the data's there, I can get it out of there. I can give you the answers that you want. Give me a list of all the people who live in Portage County who are deaf or hard of hearing who went to Lions Camp in the July 1st camp session. No problem. Okay, maybe not no problem, but yeah, I can do that because all that data, what's the person's disability? What county do they live in? Which camp do they attend? All of that data is in the database. And if it's all in the database, I can tie it together in a different way. That's the flexibility. We're also looking for accuracy. That accuracy comes from no redundant data. Again, if it's third normal form, if we follow Volker's steps, it will be third normal form. There shouldn't be any redundant data except what? What'd you see? What'd you hear? Linking fields. That's the only redundant data we have. If we follow my 10 steps, that should be the only redundant data. Now, as databases grow and new people take over, they may not, and thousands of tables and tens of thousands of fields, and somebody said, can we add this field? Maybe it gets added to the wrong place. Shouldn't. I don't think. There should only be one and only one proper place for every single field to go into your database. But there could be some redundancy after a while. This is something that occurred to me driving back from Rapids the other day about why do we care about third normal form? Well, maybe the database has just been growing, and yes, it's flexible, but we haven't been very careful when we're growing it. If that's the case, I don't think I would apply all the techniques of third normal form to a 1,000 table database. It's a little late for that. It's too complicated. When I find this is where database administrators come in. That's why the physician came up to protect us from those kind of things. We put the field in the database in one and only one place. If we find those redundancies, then it's a database administrator's job to get them back out of there again as quickly as possible if they make a mistake. Kathy?
When you're talking to a customer or whatever that you're designing this database and they think they want something, for example, hobbies, they want that in there, they're not using it now, but they think they're going to use it in the future, not really sure, really don't have a plan, but they'd rather have it than not have it. Is there any thought process as to putting something in now that may or may not be used and then possibly taking it out later?
It never gets taken out. Right? What I've discovered analyzing the Lions Camp database, there are tables in there that are empty. There's no data in them. Well, why is that? Because they thought they would need it. I thought it would be good. Occasionally the analyst says, you sure you don't want this? And we put it in there and then they don't really want it, so they don't use it. But it never got deleted. This is a database that's 15 years old. And so it never got deleted. It just sits there and never gets used. It's empty. Right? So a couple of ways of dealing with that. If they think they might need it in the future, it really doesn't cost anything. It does cost them to put it in because I have to provide, first of all, link it to the rest of my database. And then I have to provide some kind of graphical user interface, some GUI to allow them to get in there and manipulate it. Create new records, read records, update records, delete records. I don't think, have I mentioned that term in this class? Create, read, update, delete. What does that spell? CRUD. Those are the four classic things that we do to data. We create new records, we update the existing data, we read the existing data, or we delete the existing data. CRUD. Guess if you like curd better, go for it. We are in Wisconsin, right? But those are the four things that we do. And doing those four things, we have to provide the means to do that for that table. So if it's an excess table and they're willing to pay for me to do or take the time for me to do the CRUD capability stuff, I can add it. And if they never touch the form, oh well, It's always there when they're ready. Part of what we would do in a normal systems process is define requirements and prioritize them. That requirement would have a very, very low priority, and there's a possibility we never get to it. So there's all kinds of ways of dealing with, maybe I'll need this in the future.
So it's better to just like not put it in, or would it be more efficient to just leave it in?
I don't think it's more efficient either way. It just takes time to develop it. Right? If I don't develop it now and then they really do need it 6 months from now, I still have to develop it.
Would it be more difficult at that time?
No. For the recording, is it more difficult to add that functionality hobbies later? No, not really,
Same.
because it's a separate table. So I just link it into the existing tables, and we'll see some of this as we go. And developing the form to enter somebody's hobbies, it's just another form that we link to. So no, I don't think it's any harder, particularly if your database is flexible.
Would that be the same for adding or removing a field, or adding a field then?
I think so. I put it in now, I put it in later. It's really not good. If my database is flexible and my application on top of it is pretty flexible, shouldn't be that big a deal. Databases are going to grow. Matter of fact, I just got an email from Lions Camp and I said, we're rebuilding it. Is there anything you want to add? And they go, oh, sure. I'm going to give you the program or the new version of the program in September. Oh, well, in that case, can you take this and put it in here now? Oh, sure. In my spare time. But yeah, they grow. New requirements come up. States change requirements. Agencies change requirements. The world changes. When I first built this database, not everybody had an email, and Lions Camp barely had an internet connection, so they didn't use them. But 5 years later, everybody's got an email. Lions Camp's got internet connectivity. It's another good way, and so the email field got added to the database. This is not a fixed design. We're not creating concrete here. It's there. It's flexible. That's what we're shooting for. Is the flexibility. And in Programming Logic Intermediate, you're learning about the 3-tier model that's supposed to provide some flexibility to the application itself that sits on top of the data, the front end. That's what we're shooting for. But the better we build it in the first place, the more likely they are to use it, and the more likely it is going to have to be flexible because they're using it. Makes me nervous. I have an application that's being run at St. Mike's. I haven't heard from them in 3 years. They're still using it? I don't know. But they definitely aren't abusing any flexibility there, are they? Because they're using the program exactly as it sits. This is what I want. Right? I go through these steps, and when I hit one of your questions, if I'm not answering it, ask me. If another question pops into your head, I hope you're getting comfortable with the fact that I'm making you ask questions and nobody's snickered at anybody saying that's a stupid question. I don't think I listed that on any of your emails when I replied. That's a stupid question. It's just 1 point. There's no stupid question. It's hard for students to figure that out. I don't understand it. Right? So by having you do them in advance, hopefully you'll squeeze them in here now if I don't answer them as part of the lecture. All right, so here's the 10-step process. What we're trying to do here is design and build a database. The data to me is a foundation for the rest of the application. So that's our end goal. Sometimes it's hard to picture where are we going. This is 2 parts of systems analysis here. It's the analysis phase and it's the design phase. 3 parts. And it's the implementation phase. We're going to build this database as part of these 10 steps. Actually, I take that back. No, we're here to say build the database. This is design, analysis and design. And the analysis is 1 step. That's the analysis right there. What are the requirements? Give me a list of fields. What do you need stored? Either give me forms or give me reports or all that stuff we talked about. Give me a list. Lyle is giving me a list. I put it on OneDrive, so you can see it later if you wish. For right now, I'll just pull it up as a reference. He said to me one day in class that it would be nice if we had a database program to manage the clinic, the computer clinic through the door over there. Okay, I said, you're right. So let's start with a field list. If you want an application, I need a list of fields. So he gave me a list of fields, which I have modified just slightly. And this is what you'll often get. Now this looks like, to me, a relatively simple application, right? We'll be able to crank this out today before the end of class. Not quite. This is often what you will get, is an English type field list of here's what I need to store in order to keep track of the activities and the stuff going on in my clinic. Very English-like. Our job is to turn that into a list of fields. This is a preliminary field list, if you will, from Hernandez, because customer name is a multi-part field. When I get this preliminary list, my first job as the database designer is to say it's a multi-part field. What it really is the first name and a last name. And take those things apart, and we will. But this is a field list. This is what I want to store. Is it complete? Maybe, maybe not. That's part of the design process. Now again, my goal today is to go through these 10 steps relatively quickly. Just to give you an overview of what we're going to be doing, and then do it and learn some of the technicalities of each one of the steps. So I've done some fact finding. I've asked Lyle to give me a list. You all are going to help me take that list and get out the multi-part fields. A little later it says take out the calculated fields. We could, or we can leave them. We can do it now, we can do it later. This is another, you saw in the methodology in the systems class that sometimes you go in circles, sometimes you jump and come back. These 10 steps, best to do them in order. But if you see a calculated field, why not highlight it and put it off on the side someplace? Because you know, after you've had a little experience with my 10 steps, that those calculated fields don't stay, usually. So we've done some fact finding. The next thing we need to do, and this often happens while you're going through the list of fields, is start generating a list of tables. Hernandez calls this your preliminary table list. It's the tables that just jump out at me when I look at the fields. Now here we have a half a page of fields. Lions Camp, Paul, how many pages was it? 3, 4? 3 or 4 pages of fields, single-spaced. His are double-spaced. Mine are single-spaced fields, 4 pages. Doesn't matter. If it's 400 pages, what jumps out at you? You start making a field list, maybe on a separate page. I like to use simple nouns. Plural or singular, just be consistent. I tend to go plural lately, because what's stored in a table of customers? Lots of customers. I will often, in the past, I've referred to it as the customer table. I'm trying to shift over to the customers table. It's a list of customers in there. Think of database access now. What are tables? Entities, objects that store the information about one thing. Customers, the products they ordered, the orders they placed. Each of those is separate. What jumps out at you? They're nouns. These are all about students. These are all about courses. These are all about the instructor. So what we're doing here is getting a list of the ones that jump out. If you're working in a team, my advice here is do it individually and then come back together and say, what'd you see? What'd you see? What'd you see? And all those were the same. Then we get to Kevin. He said, well, I also saw this. And everybody else goes, whoa, I didn't see that one. You're right. It's there. Put that on the list. So it's an iterative process. We look at those tables and make sure our list is as complete as we can make it. It's a preliminary list. Then we are going to draw our entity relationship diagram. It's our first set of design. We've taken our lists, our requirements, and made a preliminary table list that we will use to draw the entity relationship diagram. This is where Hernandez and I differ. He sees these tables and fields linked together and he starts saying, okay, and then put your fields in the appropriate. No. I disagree. All I want is a list of tables here. That list of fields is still its own separate list. Maybe it's been tweaked a little bit to get those multi-values out of there. Put little stars next to our calculated fields. But we're not done with that field list by any chance, by any stretch. But now we've categorized the fields into tables, and we're going to draw a picture of those. And the pictures are very similar to what I was drawing on the board in the last couple of weeks, where they're just squares with lines in between. And part of this is a big step in my detailed notes. Part of that is then finding the direct relationships. Which tables are directly connected to each other? And then what's the cardinality of that? One to one, one to many, many to many? Which one of those three is it? And I will teach you how to figure that out. That's all part of drawing the entity relationship diagram. Once we've got that figured out, and notice I didn't say anything here about resolving many-to-many relationships yet. That comes a little later. 2 steps later, there's a reason why we don't do it right away. You draw your entity relationship diagram. You draw the direct relationships with lines. And you figure out the cardinality. And if it's many-to-many, the little hairs on the back of your neck stand up and you can't stand it and you want to resolve it, but this is one of those where I'm going to tell you, don't do it. Leave them. You will resolve them, I promise, but don't jump ahead. The reason we don't jump ahead is in order to resolve the many-to-many relationships, we need the primary keys for each of the original tables. So once the entity relationship diagram is done, we've got the boxes connected and the cardinalities in there. Then for each one of the tables, we figure out what's the primary key. Define for me primary key again. Isaac? Primary key?
Yeah.
What is it?
Unique identifier of each field.
Close. It's the field that uniquely identifies a record. Okay. For you, it's student ID, right? Uniquely identifies every one of you here at Midstate. What do you have that uniquely identifies you in the entire country, no matter what database I want to build?
Social Security.
Yeah, but we don't, Social Security number, we don't use that anymore. Used to. Very convenient, right? Everybody's got one, it's unique. Now you walk into Midstate and they say, what's your Social Security number? But the problem with that is there's security issues, personal security issues. And so nowadays you have your unique identifier all over the place. And everybody's got their own for you. At Lions Camp, the people who work there on the staff in the database have a unique identifier that is Lions Camp only. And then they go to Walmart or they go to their credit card company or they go to their bank and they have unique identifiers in each one of those places. There's no one anymore because that makes your security too dangerous. So we need a primary key. What uniquely describes this? For every table in our diagram, and I included in the diagram. So my diagram here is not quite complete yet. I add this. Karen?
I'm wondering then if you're gonna have to add some fields to the list.
No, oh well, like what?
Well, like a order number or something. If you've got a table and it's not clear, that any of the fields that you have your field list for is primary key, then you add another one to the field list.
Do I add one? Right. These are called artificial keys. They're not something that I would normally store. That's why the word artificial comes in. artificial keys in most database programs today are auto number fields. If there's nothing in the table that uniquely identifies a record easily, you make an artificial key. Auto number fields. Somebody else asked me a auto number field question. Where is it? Yeah,
How is that auto number field generated? Or
that's the question I'm looking for. The database does it automatically. How is that auto number field generated? Whenever you add a new record into the database program itself, Access, MySQL, SQL Server, the database program itself generates a unique number for that record. First time you add a record, you're number 1. Next time you add a record, that's number 2. Next time you add a record, that's number 3. We delete record number 2 for some reason, fine. Next record, you're number 4. What about the 2? Gone forever. Doesn't matter. Some people in their databases will write code to generate a globally unique identifier. GUID, G-U-I-D, different than GUI, a globally unique identifier. It's this big, huge monster string with 20, I don't even know how many, I'm guessing 25 characters in it. And if you do 25 raised to the 26th, or 26 raised to the 25th power, because that's 26 letters, oh, we better add the numbers. So now that's 36 raised to the 25th power. That's a pretty big number. And we're globally, uniquely identifying a record, meaning nobody else in the world, no record anywhere in the world is going to have that unique identifier. We're not using those because we're not writing global apps. That's something you may run into when you get to Skyward. Here's a unique identifier that we are assigning to this student that will never be used anywhere else in the world. How do they ensure that? I have no idea. They use code to write it, but it's a unique ID. We are just going to allow our database program to automatically generate a number for us, and it just numbers them sequentially as you go. If records get deleted for some reason, the numbers are not reused. Never reused. So an auto number field in Access, every time you insert a record, just numbers it. 1, record number 2, record number 3. What do those numbers mean? Absolutely nothing, but they're unique. It uniquely describes a record. Give me the information for student number 17. And all of a sudden, Eric's stuff comes out at me. How did I know he was 17? I didn't. Why did I ask for student number 17? I didn't. On my form, there's a combo box that says, which students do you want to see? How about Eric Anderson? Cool. Behind the scenes, combo box goes, oh, he's number 17. Go to the database, pull out 17. Those numbers mean nothing except to uniquely identify a record. Many database administrators and many database designers automatically use auto numbers for every single table. I don't go that far. I try to use a little discretion, but most of my tables are primary keys are auto numbers. So for many of these, when we define the primary key for each entity, we're just going to say, all right, we're going to make up an order ID. We're going to make up a customer ID. If we were doing Midstate, I might make a student ID that isn't even your 8-digit ID. That's the MSTC ID. I would just make a generic number, maybe. That's one of those where I might think about it. You already have an 8-digit student ID. It's one field. Why would I want to generate something else? Trevor?
I think you kind of answered it. I was just saying, what was the advantage of not using it?
Not doing it because we already have something that we recognize. All right. But most of these are pretty simple. They're always integers. So they're very easy to manipulate. In all programming languages, integers are easy, right? Compared to doubles and stuff. So they're always integers. Where your student ID, what type would you make your student ID? What type? integer, double, string, Boolean, decimal. Volker's philosophy, you ready? It's gonna be on the test in this class. I hate when Paul's in here because he grins whenever I say test. He knows there isn't a test in this class. This is important, I think. Volker's philosophy. And by the way, I'll give credit to Steve Hunt because he's the one who brought it up to me. I didn't believe it at first, but I since have adopted it. If you don't do math with it, it's not a number. String. Heard that before? Did I say that in programming logic beginning? Sounds familiar. If you don't do math with it, even though it's a number, it's really a string. Your student ID is a great example. If I subtract Miguel's student ID number from John's student ID number, what valuable information do I get out of that? Absolutely nothing. Doesn't tell me who registered first, doesn't tell me how far apart they registered, doesn't tell me anything. There are some secret codes buried in there that I discovered one day, but doesn't matter. They don't. So those should be stored as strings. About your social security number. String. Zip code. 5-digit zip code. String. You subtract one zip code from another. You can't tell what order, how far apart these cities are. You can't tell anything. Occasionally, if they have the same first 4 numbers, it kind of means they're all in the same general area, but in general, they don't mean anything. Strings. Phone numbers. Strings. Age. That's a number. I want to find out who's older, who's younger. That's math too. Comparing. See who's higher, who's lower. So that's another one of my philosophies. Doesn't quite fit in here till a little later. If you don't do math with it, it's a string. Strings are hard to manipulate, right? We're learning that in programming logic intermediate. So having an auto number field, which is an integer, is much easier to manipulate. And we don't do much manipulating with them. They have no other purpose except to link tables together and uniquely identify a record. So we use a lot of them. Now that we have the primary keys, we can move on to resolving our many-to-many relationships. Usually what works is that when you have a many-to-many relationship, there's another box in between. I drew pictures of that before, right? You just slept a box right in between those two. It's a linking table. That linking, we got to give it a name. And somebody asked, I forget who it was, I said, what do you name these things? Yeah, well, that's a challenge. Whatever you want. Whatever makes sense. Sometimes it's hard to come up with something that makes sense. If you can't, I'll give you some clues. But sometimes we can find a decent name for this. When one instance of parent 1 and one instance of parent 2 are put together, what do you call that? Students and classes. Let's see if I have this ready here. That's not what I, yep, it is. Oh, come on. Students and classes. Let me draw it on the board. For those of you who aren't here, I'm sorry, my virtual machine, oh, there it goes. All right. I think this flu season is just going to cause me all kinds of grief. I'm recording what I wouldn't usually record, but we're missing a lot of people, and I don't want them to miss this important stuff. So this is my students table, and this is my classes table. And those will be connected. Good luck with that. Already lost my toolbar. Now, when you draw entity relationship diagrams, I have to practice because I've forgotten how to do this in Visio. But when I notice there's an arrow there, we don't want any arrows. There's no one-way arrow thing here. It's not a flowchart. So I have to remember which tool I use to get rid of that. There is a way to quickly do it for all of them, but there is also a way to do it so they don't get put on there in the first place. One student takes many classes. One class is taken by many students. So this is just another example. It is not the last one by any stretch of the imagination of how to do the resolution. Oops. So there's a box in between. And what my notes, the reason I'm talking about this is what my notes say is here's a question you ask yourself. When one student is combined with one class, what do you call that? So Matt's got lots of classes, right? At least a couple, 3. And he's one of many students in here, but it's him. He's in here. Him. What do I call that? An enrollment, a registration. If you think occasionally if you ask that question, you find yourself an example, Matt in RDD, what do we call that? He's enrolled in RDD. Oh, okay, there's a name. It's enrollment. He registered for it. He's registered. Often there's a name. Sometimes there's no name. So it's a class student. That's gross, but I can't come up with anything else. So what we have in class student is who is registered in this class. Okay, so that's an example of how you solve that. What do I call the new entity? Sometimes you can find a name, especially when there's a group of people like this, somebody comes up with it. Sometimes a little bit of practice, you'll come up with a name. Often a user can help you. Then we reevaluate that cardinality. It's not 1 to 1, or it's not many to many anymore because now there's a table in between. Please. Yeesh. No, it's not time for a break. Don't get your hopes up. Let's get close though. Okay, this used to be many to many, from here to here, right? Now there's a box in between. And again, I'm going through this quick. If you're getting a little confused, hang in there. We're going to slow this whole process down and do it for real. Just giving you an example. Often, and this is what my notes demonstrate, often the new relationship, the new one that you just added, is a many, here and here. This is now a one-to-many relationship, and this is a one-to-many relationship. I'll explain why later. For right now, realize that most of the time, this is that box you just added. It gets the M's and the 1s go back to the tables that we had there before. Most of the time that works. Still got to analyze it. Sometimes it fails, but most of the time it works. Then we need to determine the keys for the new entity. That box that we just created in between, that enrollment table, what are the primary keys for that? And as it turns out, is probably the keys from the 2 parents. If I want to describe Daniel in this class, or Matt, excuse me, and register a class, they're linking redundant. On all 6, off shows me the